if sodium sulphate is considered to be completely dissociated into cations and anions in aqueous solution. The change in the freezing point of water when 0.01 mole of sodium sulphate is dissolved in 1 kg of water is. Now you have to find out the change in the freezing point, right? So that is your delta TF is equal to the freezing point depression constant multiplied by the molality. Okay, so here students, sodium sulphate is completely dissociated, that is Na2SO4 gives 2Na plus of SO4 2 minus. Right? Now, your Want half factor is equal to the total number of ions formed after dissociation. Right, here the degree of dissociation is 1 because it is completely dissociated. Right, so here in this case I will be equal to 3. Right, now in this case let's find out the delta TF, and it is equal to KF. What is K? Now I is 3. What is KF? 1.86 multiplied by, what is the molality? See, we have provided straight away with 0.01 mole, right? And that is dissolved in 1 kg of water. So that is, what is molality? It is the weight in grams, or sorry, what is molality? It is the number of moles of solute dissolved in 1 kg of solvent. So here it comes out to be 1. Right? So what will be your answer? It is 3 multiplied by 1.86 multiplied by 0.01, and it gives you 0.0558 Kelvin. Okay, so the freezing point depression is equal to 0.0558 Kelvin. Right? So this was your question. So students, do remember that. Do just first find out whether the solute which is added is undergoing association or dissociation. Okay, and if it is partially dissociated, what will be there? There will be degree of dissociation. Okay, that is alpha. Alpha is what? The number of moles of the substance formed divided by the total number of moles. Okay, now here if I find out the degree of dissociation will be the number of moles of substance formed is 3, and divided by the total number of moles is how much? This is the total number of moles from which we started, so it comes out to be 3. Right? So this is the thing, students. So in case of, it's just an advice that when there is complete dissociation, just take the Want half factor as the number of ions formed. Okay? Because here the degree of dissociation is complete. In this case it is completely dissociated. Okay, now let's take up the next question. So this question was from solutions, and the marking scheme was +4 and -1. Right, so whenever there is complete dissociation into ions, the Want half factor is equal to the number of ions formed. Is my point clear?